Hello and Assalamualaikum to all panelists and viewers for my video presentation. This video is in purpose to present about my final year project with project title of IoT based muscle fatigue monitoring system in weightlifting. My name is Amirah Binti Hazlan and I will be the presenter of the video. My supervisor is Associate Professor Dr. ZULKIFLI Muhamad. Please enjoy my video. Essentially, any physical activity involves injuries. Muscle injuries are prevalent among athletes and have a major effect on the accomplishment and performance of an athlete. With proper stretching and warming, muscle injuries can be avoided. However, muscle fatigue may also occur. The physical condition of individuals, in particular sportsmen, is extremely difficult to track. In this project, muscle fatigue can be monitored using internet through a mobile application. Blink application will be used, which is majorly utilized in developing new IoT, which is Internet of Things system. The complete system is composed of a power supply, EMG sensor, ESP32 LoRa Wi-Fi module, and microcontroller. This technology is suitable for monitoring fatigue condition, which is used to real-time monitoring of fatigue for weightlifting person. So, this video will present the development of a muscle sensing system for the purpose of tracking muscle fatigue in weightlifting exercise. For the next part is problem statement. Most of the athletes experience muscle fatigue during their training days, thus it can give a big impact on their performances and training. Nevertheless, to track the weightlifter and athlete physical condition is challenging, and because they cannot estimate on how far their injury can be. Despite there are some other systems that can monitor muscle fatigue, most of it only can be monitored using personal computer, which is PC. It is difficult for coaches and athletes to monitor muscle performance and getting injury because most of the systems nowadays are not portable. Since the athlete need to train in various places, a monitoring system that is portable with all the smartphones and devices are suitable to be used. Based on problem statement from the previous slides, three objectives will come out. The first objective is to develop a muscle fatigue monitoring system where the trainer or athletes can monitor and track their muscle performance and injury using Internet of Things mobile application approach using weightlifting. For the second objective is to create a user interface that is easy to monitor muscle fatigue and user friendly. For objective number 3 is to test the performance and efficiency of the system. The scope of this project is to develop a muscle fatigue monitoring system by using IoT and can be monitored in real time by using ESP32 and Blink application. The muscle fatigue system gather data from EMG sensor and then transfer to Wi-Fi module, which is ESP32. Then the data will generate and transfer to Blink application and display the muscle activities. The limitation of the project are: the first one is integrating muscle fatigue monitoring system using ESP32 and Blink application. Limitation number 2 is developing an algorithm for the ESP32 in order to monitor muscle fatigue and prevent muscle injury from happening. Then limitation number 3 is the system is limited for weightlifting exercise with 5 kg load. To achieve all three objectives in the studies, the project flowchart are created. Firstly, the sensor need to calibrate. Then proceed with developing algorithm for the system by using Arduino IDE. Next, proceed with uploading algorithm to Wi-Fi module. If the algorithm is successfully uploaded, the research objective number 1 is achieved. For the next step is create user interface using Blink application and then upload the algorithm to Blink application. If the algorithm uploads successfully, the research objective number 2 is achieved. For the next step is experiment setup and test the system performances. Then proceed with data acquisition and validation of the data. If the data validation have the same trend from the previous studies, the research objective number 3 is achieved. In this project, the system will be focused on detecting muscle fatigue during weightlifting activity. The system will start by connecting the microcontroller, which is ESP32, to the internet via Wi-Fi. The internet connected successfully, ESP32 will connect to Blink application server. Once the server connection is intact, the application can receive the data obtained from electromyography sensor and display it in the mobile application. Furthermore, the Blink application will give signal if the user will be experiencing muscle fatigue during conducting exercise. For the next step is designing hardware prototype. The figure shown the circuit diagram and the casing hardware. To maintain the muscle performance of the athlete, a real-time monitoring system is done by measuring the voltage transferred from the EMG electrode to LCD display or ASP32 Wi-Fi module, microcontroller and Blink application. The LED indicates the indication of muscle during exercise. As the user conducting some exercise, muscle will be in contraction and yellow LED will turn on. Furthermore, LCD display will display contraction to inform the user their muscle condition. Red LED will light up when the user will be experiencing muscle fatigue, and LCD display fatigue to the user. The LED indicator and LCD display ensure the user can track their muscle condition during exercise easily. 3D modeling casing are shown for muscle fatigue monitoring system hardware. The casing will cover all the jumper wire and make sure is user easy and comfortable to use. For the experiment setup, a group of 3 individuals with ages 21 to 35 years were selected. The chosen subjects are from different range of status such as sport person and inactive person. The subjects were assigned to lift and curl 5 kg weights of dumbbell using their dominant hand until they got tired. The subjects need to do 5 sets of dumbbell weightlifting curl, and each set consists of 5 pumps and 10 seconds of resting. The muscle conditions such as muscle contraction, rest and fatigue were recorded by the muscle activity monitoring system developed. The table below shows the physical characteristic of all subjects. For recording, the biceps area was cleaned to reduce skin to electrode resistance. 3-channel electrode were used and placed according to the direction published by the surface electromyography non-invasive assessment of muscle, which we call SENIAM, as shown in picture shown. The electrode placed to biceps brachii as yellow and green electrode are input and green electrode as reference electrode. Two pre-gel electrode channels were placed on the muscle belly for each muscle separately with minimum distance between them. The third electrode channel, being the reference, was placed on the wrist. The gel helps to enhance the conduction of muscle signals from the body to the electrodes by minimizing impedance. For the next section is result and discussion. For the serial plotter in Arduino IDE, the plottation the muscle activity during weightlifting is conducted. The graph obtained during weightlifting exercise is in the video shown. The user can observe the muscle activity from serial monitor whether the muscle is in contract or rest condition. The subject need to lift 5 kg load of dumbbell with 5 sets of exercise and 10 seconds rest for each set. Then the result in serial plotter is observed. For the next part is the result in the Blink application. The picture shows the layout of the mobile application and graphic user interface. Superchart is used to monitor the muscle activity when conducting exercises. The increasing and decreasing of amplitude, which is millivolt, of muscle can be monitored in Blink application. The Blink application will visualize the EMG reading and notify the user if muscle is starting to fatigue. For Blink application, the superchart in Blink were obtained from coding that were already set up in Arduino IDE. However, there are slightly delay of data received from microcontroller to Blink application, which is 1 second delay approximately. The communication between application on the mobile and ESP32 is not direct, but through Blink Cloud, which means ESP32 is sending data to the cloud and Blink application is reading this data. Some delays appear due to traffic on the internet, and it is really hard to predict how much delay there will be between blinks. Nevertheless, data received from EMG sensor to Arduino IDE have some delay about 0.1 seconds, but the delay time can be considered as optimum data received as it does not affect the monitoring system. As for the hardware, the LED indicates the condition of muscle during exercise. As the user conducting some exercise, muscle will be in contraction and yellow LED will turn on. Furthermore, LCD display will display contraction to inform the user their muscle condition. Red LED will light up when the user will be experiencing muscle fatigue, and LCD will display fatigue to the user. The LED indicator and LCD display ensure the user can track their muscle condition during exercise daily. For the next part is data acquisition. The system will visualize the muscle activity through amplitude, millivolt. The peak amplitude from flex position and relax position are collected in every phase and simplified to mean amplitude. From the experiment conduct, the mean value of flex position and mean value of relax and rest position is recorded to observe the muscle condition on each subject. For mean flex position, each peak amplitude, which is millivolt, or for every phases were recorded, while for mean relax or rest position, muscle rest amplitude for 10 seconds before continuing to next phase is recorded. The muscle signal amplitude depends on the strength of muscles and the force applied, which varies from person to person. The EMG result during dynamic contraction of bicep branching muscles at elbow flexion was different for each individual, as shown is on the table. It was seen that after load lifting, the relaxed amplitude of the bicep branching was increased compared to the initial relaxed state. This shown that after weightlifting, the muscle happened to fatigue, resulting in low voltage. The extent of fatigue depends on the state of muscles at initial activity. For the system results, data from serial plotter in Arduino IDE showing the muscle activity during subject 1 conducting weightlifting activity in phase 5. Muscle fibers generate electric activity whenever muscles are active. During muscle contraction, the peak value of the amplitude is more than 4000 millivolt when lifting dumbbell with 5 kg load. Muscle amplitude throughout the muscle rest is observed in the range of 1000 to 1500 millivolt. The amplitude value during muscle rest is throughout every phase is lower than muscle contraction due to a lesser amount of muscle activity. However, muscle fatigue amplitude observed is lower than normal muscle rest amplitude, which is less than 1000 millivolt. It is important to monitor the amplitude changes. The amplitude, which is in millivolt, were different from each subject. When bicep branchie is in rest condition while holding the load, small amount of motor units is recruited, hence producing a small signal. This signal gives small amplitude. When voluntary contraction of bicep branchie is done with load of 5 kg, the increase of voltage was noted, which meant the number of activated motor units had also increased as bicep branchie required more strength for contraction. The results for different individuals were different according to the muscle strength and force required for the muscle contraction. For the next part is electromyography sensor data analysis. Figure A and B show the performance of muscle state that was constructed according to the previous table. Figure A is constructed to show that pattern of mid amplitude during relax and rest position with respect to lift phase for every subject. The EMG signal monitored in subjects with fatigue muscle shown a decreased amplitude. Muscle fatigue state is a state when capability of muscle to contract and generate force is decreased. It is generally described as a point when the participants can continue the task further in time. It is observed that the amplitude of EMG signal decreasing after phase 2 from both graphs. The decreasing pattern is expected as the subject is starting to be exhausted due to the decreasing oxygen supply. Among all the phases, phase 5 experiences the lowest voltage that indicates maximum muscle fatigue by doing lifting tasks as compared to phase 1, 2 and 3. At that point, the participants will utilize their all energy to lift the load. From figure A, the result can be concluded that subject 1 has a good muscle condition as the subject is a sports person and already made weightlifting exercise as a routine. Thus, it makes subject 1 muscle strength in biceps branchie take more time to fatigue. Subject 1 has a minimum value of mean amplitude from phase 1 to phase 3 during relaxed position compared to subject 2 and 3. This is because subject 2 and 3 are not familiar with weightlifting activity and require more energy to lift the load. Even though subject 2 is a sports person also, drastic changes in decreasing mean amplitude occur after phase 3 because muscle strength activity is lower than a person who actively conducts weightlifting as a routine. Same goes to subject 3. An inactive person requires more energy to lift the load. Subject 3 shown that he started to fatigue after phase 3 and begin to tire during lifting. It is shown that muscle strength of the subject 3 are lower than subject 1 and 2. Figure B shown a graph of mean amplitude during flex position graph versus weightlifting phase. At phase 1, all the subjects experience highest mean amplitude. After phase 2, the mean amplitude for every subject started to decrease. Overall, the decreasing pattern in flex and relaxed position from both graphs has shown the results have the same trend from previous studies. Azhan and Gaurav Raj stated that the decreasing amplitude, especially during muscle rest from the initial state, are indication for muscle fatigue to begin. For the last part is conclusion section. Overall, a system has been successfully developed to monitor muscle fatigue whether athlete or trainer can track their muscle condition using IoT approaches. So, objective number 1 has been achieved. Next, user interface successfully been created by using Blink application to monitor muscle activity and user-friendly. This is proof that objective number 2 is achieved. Then the performance and efficiency of the system has been tested on weightlifting exercise, and the outcome of the result has been proven that the result is acceptable and have the same trend from previous studies. These studies concludes that right bicep branching faces muscle fatigue condition as the weight load applied was 5 kg. The study concludes that muscle fatigue starts to occur when muscle rest in initial state is higher than in final phase during weightlifting. Same goes to flex position state. The mean voltage will slowly decrease as the subject felt tiredness and nearly unable to do anything lifting anymore. The continuous manual lifting tasks will lead to low productivity and low performance in their work. Also, this system can be used as IoT monitoring system for recording EMG data and send data wirelessly via Blink applications. Based on the system running evaluation, it needs a steady internet connection to make sure the system is running smooth. As for the recommendation, the system should be widely used in sports industries. The system should be able to detect muscle behavior on various exercise or other sports. That's all from me for my final year project presentation. If there is any question regarding to this video, please don't hesitate to drop your message. Thank you for your time and Assalamualaikum.